Hello students, welcome to today's lesson. In this lesson we're going to look at protocols. It's one of the key components, one of the important topic when it comes to computer networks or networking. So in this lesson we are going to define what a protocol is. We're going to look at the element of a protocol, what makes up a protocol. And we're going to look at a list of certain protocols and their usage in data communication. So now the first question is, what is a protocol, by the way? We said a protocol is a set of rules that govern data communication. So these are a set of rules that governs what? Data communication. If in data communication or in computer networks, in networks, we say the network it's when two or more devices or computing devices are joined together. Now, these two devices need to communicate. They need to send and receive information. But there are certain set of rules that they need to follow when they are communicating their data. Okay, they need to follow certain procedures. They need to follow certain standards for them to communicate. They don't just communicate out of blue. There must be some certain rules that they need to adhere to for them to communicate. For example, let's take a typical example or a simple scenario that will help us to understand more what a protocol is. Take an example. If we have got 5 students in a classroom and these students, they are given a task, and their task is to define what a protocol is. So go into a group, discuss what a protocol is. So let's say a lecturer gave you the task in class to go and discuss what a protocol is, and you are 5 in groups. Okay, now let's say, for instance, if all 5 of you speaks different languages. If the first student speak Setswana, the second one speak Chiherero, the next one speak Shivambo, the next one speak San language, and the last one um, speak Silozi. Now, this is going to be a barrier among or during your discussion, because each and every student, all 5 of you, only know your languages. So when it comes to discuss this in a group, it's going to be a barrier because you won't understand each other. So there's no common language that is going to be used when you are discussing this in your group. So now, to break that barrier, as a lecturer, I need to do what? To introduce or to give you like a set of rules or standards or something that you need to use so that you can all able to hear each other. Okay, then I'll ask you to have your discussion in English, and that way you can now able to understand one another. And that's what basically a protocol does. So when it comes to data communication, because we have got different vendors that are manufacturing our devices that we are using to connect to internet or to different networks. So now these vendors or these manufacturers need to follow certain, these devices, when they're joining on networks, they need to use certain rules, some certain protocols for them to communicate to one another. Okay, so irrespective of which manufacturer is that um, device is. So if it follows those rules, then they can able to join any network, and follow the certain procedures or rules that are outlined there, then they can able to communicate. Okay, for an example, if you're sending an email to someone, you need to follow certain rules. So there is a protocol for emails, for sending and receiving emails. Okay. For example, another example is when you join in your PC, your device, when you come to a certain Wi-Fi, or um, you are accessing an organization Wi-Fi. Okay, so your device need to be assigned an IP address. So this IP address is assigned automatically by a DHCP server. So there is a protocol that is used as well when these technicians are configuring what the DHCP server. There is a protocol that is used there in between. Okay, in that communication. So there's so many protocols out there, which we are going to look at some just in this presentation or in this lesson. So basically, that's what a protocol is. We say it's what? It's just a set of rules that need to be followed when you're communicating in different networks. Okay. So we said a protocol defines what is communicated, how and when to be communicated. So this rule defines or it tells us what do I need to communicate. If I'm communicating, if I'm sending an email, right? If I'm sending an email to the next person, there must be a protocol for that. That can govern or that should govern our communication between the two of us. So email protocol, we have got SMTP, we have got POP3, and so forth and so on. So these are some of the examples of protocols, but we will look at that towards the end of this lesson. The protocol also have got elements. A protocol consists of, or it's made up of elements, certain elements, or it looks at certain things, or there are some certain components within a protocol itself. Okay, so we call them the elements of a protocol, and there are three of them that we're going to discuss here. We have got syntax as one of the as the element, and we have semantic as one of the element of a protocol, and lastly is timing. So these three elements makes up what a protocol. It makes up a protocol. So with semantic, we refer to as the structure or the format of the data, because the data that is being transmitted would definitely have a structure. It will definitely have a format, meaning the order in which they are presented. For example, the simple protocol might expect the first 8 bits of data to be the address of the sender, and the 8 bits to be the address of the receiver, and the rest of the streams to be the message. So when you are sending a data, it have got different portions or sessions, if I may say. So now a protocol will assume that the first 8 bits of your data is the IP address, of the sender. And then the next part is, the second part is the IP address of the receiver, and then followed by the message itself that you're sending. So that is a structure. That is a structure that a protocol should expect your data to be in. Okay? So that is actually the format or the structure. So that's what we refer to as the syntax. The next one is semantics. As the word semantics, it refers to the meaning of its sections. So now, as we know that the data is broken down into smaller pieces as it's being transmitted from a source to the destination. Okay, so you've got a large block of data, and this block is divided into smaller manageable pieces. And then now these pieces, because now this data is broken down into pieces, so when it gets at the destination, it has to be reassembled to um, um, so that it get back to the original message that was sent. So, but now when this block of information is broken down into pieces. So these pieces are not sent in the order in which they are. Okay, let's say you've got a block of data, and then it's broken down into 5 pieces. So, and then you give them, these pieces are labeled. They're given what you call sequence numbers. So once they get to the destination, they are arranged accordingly or according to their sequence numbers. And then this, it helps the source or the the destination to arrange these bits of info or bits of data. I mean these these pieces of data to be regrouped, and the original message is formed. Okay, so this semantic, actually it means now the section, it means the section of each of these bits. With the semantics, when these pieces are broken down, they are given, they are attached some certain information, or they are wrapped around certain information, protocol information. As we said that it should have the source and the destination IP address. It must also have got the sequence number. There must be a type of a service field also indicated there, and so many things that these pieces of data contains. Okay, but with semantics, just the meaning of each of these sections. Okay, which we did in the previous lesson. So that is more on semantic. And with timing, the term timing refers to 2 characteristics. So the timing carries 2 characteristics. So it defines when the data should be sent and how fast. So if this data, the data which is broken down into smaller pieces, so if the first piece is sent, the next one has to wait maybe for 2 milliseconds, and then it's sent. It's being sent again. Okay, so what to be sent and how fast. Okay, so the second second fragment has to be sent after the first one have arrived. Okay, and then when the destination or the destination node receive this data, it has to acknowledge, it has to send an acknowledgement message back to the source, notifying it that the message that was sent, it's received. And if the data packet is lost along the way due to some certain factors or things that may be involved there, then an acknowledgement message is also sent, or the source will assume that the time that I'm supposed to wait to receive the acknowledgement message have elapsed. Then it will assume that that packet is lost, and then it will resend another copy. So that's how the whole process actually goes. So we said we have got the syntax, we have got semantics, and timing. So those are the elements of a protocol. Now moving on to some certain examples or examples of protocols that we have and their usages or their usage. We have got TCP. This is one of the protocol. We have got IP, which is Internet Protocol. We have got UDP, User Datagram Protocol. We have got HTTP, which is the most widely used protocol. And lastly, we are going to look at FTP, which is File Transfer Protocol. So now let's look at TCP. What is TCP? How does the TCP work? It's a connection-oriented protocol that offers end-to-end packet delivery. Meaning, with end-to-end, or with a connection-oriented, it means there must be a connection established between the source and the destination first before the actual data is sent. So a source has to send what we call a dump packet to check if the channel is being used or not. So if the channel is not being used, then that connection has to be established. It has to be available only for those two nodes to send or to communicate data. So that is TCP. There must be a connection. It is a connection-oriented protocol. So there must be a connection first established between the source and the destination. And it offers end-to-end packet delivery. So meaning, if you are using TCP or if TCP is being used, then for sure you should know that your packet is that you are sending or that you're transmitting is going to be delivered, because it offers end-to-end packet delivery. There is no way that your packet is going to be lost along the way. So it will definitely, it is 100% certain it will reach the destination. Moving on to the next one, the IP, which is the Internet Protocol. It's a connectionless and it's unreliable. So with IP, the Internet Protocol is opposite the TCP, because with TCP we say it's connection oriented and it also relates, it's reliable, it's a reliable protocol, unlike the Internet Protocol, which is connectionless and unreliable. So there's no guarantee that if TCP is in place, then there's no guarantee of what? Of a successful transmission of data. Okay? So now in order to make it reliable, because we say it is unreliable, it must be paired. So TCP, I mean IP, the IP protocol has to be paired with another protocol to make it a connection oriented and more reliable. Because if it's just used on its own, then there is no guarantee that our data is going to reach its destination. So that's on Internet Protocol. The next one is UDP, User Datagram Protocol. So the UDP, like IP, so these are the UDP and the IP, they're brothers and sisters because they behave the same way. So it's a connectionless and it's also unreliable. So it does not need connection to be established like what TCP does, and it's also unreliable. It's unreliable, excuse me, and it doesn't require making a connection. This is what I've said, because we say it is connectionless. So it does not require connection to be established. We say it's unreliable, the unreliable protocol, and there's no mechanisms in UDP that guarantees what? The mechanisms there are no mechanisms that are ensuring us that the data that is sent is received. So this has to be, if you want the reliable and connection-oriented connection between a source and the destination, then the TCP is the best protocol to be used in that scenario. Okay, now moving on with the last two protocols that we have here, we have got the HTTP, which is the Hypertext Transfer Protocol. And we are saying it's a communication protocol. It defines the communication between the browser and the web server. So this one is the most widely used protocol because let's say take an example of a student completing his or her assignment. So definitely he will need to search the information on the internet, and he uses or she uses the web browser to request for files from a web server. So now the connection, I mean the protocols that is in between there that handles the session, that session is what is referred to as the HTTP. And you also call the request and response protocol because you as a user, you request for a web page and then the web browser respond by displaying or giving those requested web pages. And then the last one is FTP, which is File Transfer Protocol. So this one is basically used in transferring of files between computers. So a user can log on to a remote computer, then browse um, through the files. You can either download the files or you can upload the file. So in that scenario, in that case, the FTP is the only protocol that can handle that can be used in that regard. Okay, so these are just a few examples of different protocols that are used in data communication, but there are many of them out there. Okay, we have got the DHCP, we have SMTP, we have got POP3. So these are all different type of protocols, and they are also used at different services or in different cases or different um, scenarios or in different purposes. So for today, let's just end here and then join me again in the next lesson. Thank you so much.